Hello, welcome to week 3 of ESM 101 Lab from Portland State University. And again, I am the graduate teaching assistant Alex Staunch. And bear with me, I'm kind of getting over a cold. Hopefully it doesn't sound too raspy or nails on a chalkboard-ish. But today we will be talking about species distribution as well as their prevalence or presence within environmental systems. So basically we are trying to make assumptions of the environment based upon how species disperse within their communities, and then also look into the historical records of a area or possibly your study site based upon the species that are present. Species presence, distribution, and why they are important. So species distribution can tell you a lot of things about the environment or the ecosystem that you're in. So the way that species are dispersed basically provides you with insight to resource availability. So the amount of nutrients, the sediment types, as well as their depth, their water availability, the air quality, any pollutions that are present, as well as possibly sunlight availability. And we're going to get into the three main distribution types in a moment, and you'll kind of see how abiotic or resources factor into the distribution of species. And then the presence of species within an area can provide you insight or provide a history to that region. And an example of this would be the fact that if you're in the Pacific Northwest, Washington, Northern California, or Oregon, we're an area in which we have historically been dominated by conifers or evergreen trees. But there are big blocks of land that have a large amount of alder trees in these areas. And the reason that occurred is most likely because there was logging that had historically been occurring within the area. So these areas have been clear-cut in the past. And alders come in because they are early successional species. So they can be seen in a way as a weedy tree species. They're the first ones to colonize an area. So they come in, they colonize it very easily, they grow very fast. And then there is no sources of new input for these conifers in the form of seeds or seedlings, because all the parents have been taken out of the area. And now you have a forest that's dominated by alders, when historically, and what it currently should be, is a conifer-dominated forest. So the presence of alders indicates clear cutting in the past. So you can find this in all sorts of regions and all sorts of ecosystems and environments in which mankind, or maybe a large natural disturbance, changed an area, and that species composition basically had an overhaul as well. So also in these areas, if there's a large amount of early successional or weedy species present, that again also indicates a disturbed or unhealthy system in the past. So when you're carrying out your study site, hopefully you were able to identify a majority of the plant species in the community and look up enough information to indicate if they are invasive or early successional native species. And that would indicate a disturbance had occurred in the past. And this picture right here kind of goes along with species presence as an indicator of human dominance or impact. So this is a study site that is in central Massachusetts. It composes, I think, 3 counties in area, so it's quite large. And the idea here is that the researchers, based on historical records, looked at the prevalence of maple trees before humans got here. So in the early 1800s, they were able to construct a forest and see that maple trees composed anywhere from 5 to 20% of the species of the individuals within these forest systems. But now, in the 1900s, they did a similar survey and found that maple trees now compose anywhere from 30 to 50% of the forest tree community. And this is due to the fact that when we colonized central Massachusetts, we basically cut down every single tree within the forest in order to make farmland. So this whole area was converted from forest to farmland in the 1800s, and then in the early to mid 1900s, when everyone was migrating from the rural areas to the city, these farmlands were allowed to naturally regrow. So maple trees, an early successional tree species, dominated these systems and grew up very thick and quickly, and they now compose the main species within these forests, when historically it didn't usually used to be that way. And what used to be dominant before humans essentially arrived were chestnuts and oaks, and we have devastated those those tree communities from the chestnut blight, which wiped out all the American chestnuts, as well as oak trees take a long time to regrow, and they don't produce as many seeds as maple, so therefore their ability to basically recolonize and in competition with maple trees is very limited. So jumping into the three types of distribution that we see in nature. The first and most common is clumped distribution. So you find this in areas in which resources are patchy. So basically, an idea here is if I was to cover an exposed area of lawn that had been torn up and just soil, if I was to cover it with a specific seed, say fringe cup, and I expected this fringe cup to grow across the whole lawn, and the next year I find that the fringe cup is only growing in specific areas and patches, this could be due to the fact that water is present in only a few areas within my lawn, or nutrients vary within the soils. So although the seed may have been dispersed evenly and uniformly across this area, the plant will only germinate and grow where resources meet its needs. And then we also see clumped distribution due to social interactions. So here you have pack animals that hunt in groups and raise their young together, and then we see clumped distribution as a protective agent. So these species get together because if there's more people around you, most likely you have a less of a chance of being eaten. Uniform distribution occurs in areas in which resources are limited. So in this picture here with the brush in a desert-like environment, you have them spaced out because water is the limiting factor. So here they have roots that not only go very, very deep to hit the water table, but they spread out laterally in order to get as much water that hits the surface as possible. So it's their large root masses that are limiting their growth and their dispersion within the area. Random distribution used to be one of the rarest types of distribution that's naturally found in the environment. So this is found in environments where resources are evenly dispersed. So it's uniform across the whole area, which very, very rarely happens, which is why we historically did not see this in a lot of areas. But now we are seeing more species with random distribution due to the fact that we're having an influx and an increase in invasive species. So invasives are so successful due to the fact that they are generalists. So although specific resources may be limited or patchy, invasives or weedy species can grow within a range of this resource. So they can grow where there's low light or high light. They can grow where there is a lot of water, where there isn't a lot of water. They can grow where it's hot, where it's cold. Basically, across one whole area, they can grow wherever because they are generalists when it comes to specific resources.